An infinite line of charge lambda per unit length is placed along the y-axis. The work done in moving a charge from point a comma 0 to b 2a comma 0 is. So now for this question, just have a diagram. So this is our diagram. Now along this line we have a lambda unit per length charge density. So now we are moving from point a comma 0. So a comma 0 is this, let's say this is a comma 0, and we are moving a comma 0 to 2a comma 0. Okay, and this is the y-axis and this is obviously x-axis. So now the work done in moving a charge q. So we have a charge placed at q and we are actually finally going through this distance. How much distance we are covering? A distance we are covering here. So what should you do? So you need to write work done for small elements. Which small elements? So suppose randomly this point charge is somewhere at this distance away, which is x distance away from the point or origin. Now suppose in moving this charge dx distance, how much work this will be doing? So dw will be equal to q into v, or I should say dv, right? So now w will be is equal to integral q dv. Now what is the value of q? Obviously it is q only. What is the value of dv? So dv we need to calculate. So we know that because of a lambda charge density, electric field at any distance, let's say x, will be 2k lambda by x, right? This formula we know. So if we know this formula, and obviously we know that E is equal to minus dv by dx, so we can write like this. And if we know that, then we can calculate dv from here. That would be 2k lambda by x into dx. So now we can actually substitute this value here for dv. So minus 2k lambda by x into dx. Now what is the limits for dx? So obviously we are moving from point A to point 2a. So obviously limits are going to be of x equal to a to 2a. Clear? How do we get it? So of course you need to remember this formula. Now what is the common? So common things are here, minus 2k lambda into q. These things are common. We get integration dx upon x a to 2a. Fine. Now if you put the value minus 2k lambda q, this will become ln x, and limits you need to substitute a to 2a. So if you put the limits minus 2k lambda q, you will get ln 2a minus ln a, which gives you 2k lambda x. This will be ln a minus ln 2a, correct? So now solve it. So let me just remove it to solve this thing. So we will be getting v. So basically this v is nothing else, work done. So total work done. So w will be equal to 2k lambda x ln 2a by 2a, correct? So this will be cancelled out, this will be 1, and we can put the value of k. This is 1 upon 4 pi epsilon naught into lambda x. So lambda q, this will be lambda q into ln 1 upon 2. Fine. So we get 2. So we get 1 upon 2 pi epsilon naught lambda q into ln half. This should be the right choice. So option number 2 will be the right answer, correct?